Alright, so for this video, I am going to show you the different types of numbers. Specifically, I will discuss the real number system. By the way, if you see this kind of R, that's the symbol for the real numbers, okay? So real numbers are divided into two categories or classification. So we have the irrational numbers and we also have the rational numbers. Of course, there's a big difference between the two. The first is, let's define what irrational numbers are. These are numbers that can't be expressed as a fraction of two integers. Okay, so let me just be clear by this. We can actually approximate them. Like there's an approximate equivalent fraction, but it's not exactly equal to that fraction. Okay, just let me make that clear. We can approximate them, any irrational number, we can approximate them to a fraction, but it's not exactly equal to that fraction. So that's the big difference between irrational numbers and rational numbers, because rational numbers, we can express them as fraction of two integers exactly. So for example, zero point 0.5, that's one half, exactly one half. Let's say 2 over 5, right? Or sorry, 0 0.4. 0 0.4 is 2 over 5. Okay? So those kinds of numbers are rational numbers. We can express them as fraction of two integers. The rational numbers are divided into two. We have the non-integers and the non-integers. Of course, I think you're familiar with the non-integers. It's divided into two. There are two non-integers classification of numbers. These are the fractions and the decimals. Now, I get it. Sometimes the confusion is if it's negative, then it will be integer. No. If it's negative one half, it's a fraction. It's not an integer. If it's negative 0.3, it's a decimal, not an integer. So integer is not a fraction and not a decimal. It's composed of three things. Negative numbers, 0, and positive integers. Okay? Now let me again repeat that. If it's negative one half, it's not an integer. It's a fraction. It's a non-integer. If it's zero point 0.3, it's not, or sorry, negative zero point 0.3, it's not an integer. Although it's a negative, it should be decimal. All right. Now, positive integers are also called counting numbers or natural numbers. Well, the reason behind that is because when we count, we start with 1, right? 1, 2, 3, 4, 5, etc., etc. We don't start with 0. If we add 0 and positive, that is what we call whole numbers. Okay? All right. Now, let me just give you some examples of irrational numbers. All right, so pi. This is the first 100 digits of pi. So, you might be thinking, well, pi is just a decimal, so that means it's a non-integer. Well, no. So the difference is that if you have a decimal that is, there are two things, either terminating and non-repeating, but the non-repeating part is you can predict the next number or the 100 number. So let's say, let me give you an example. Let's say 3.14, okay, and there's a bar on top. So the bar on top is telling us that this is 3.141414. So the next numbers are predictable. Okay? And it ends with just 1 4. Although it's infinitely 1414. Okay? Let's say 4.5. Obviously, that's a terminating decimal. It stops at 5. But for a decimal like this, which is irrational, if you look at the numbers, look at that 1 4 1 5 9 2 6 5 3 5. You will not see any pattern there. Okay, you will not see any pattern. So that's the difference between an irrational number from a decimal. Okay, so a purely decimal can either be terminating, it can be uh, non-terminating, but it should be repeating. So again, if it's non-terminating, it should be repeating. But if it's a non-terminating and non-repeating decimal, that should be an irrational number. Okay. Another example is e. The value of e, it's approximately 2.72. So we approximate that as 2.72. For the pi, we usually use 3.14. Okay, some math teachers, they use the equivalent fraction of that. It's not really equivalent fraction, but it's approximate fraction. That's, I believe, they're using 22 over 7. But 22 over 7, if you um, I'll write here 22 over 7. Some math teacher, they substitute 22 over 7 per pi because the first the next two digits after the decimal points are 1 and 4, 3.14, but the next after that is 2. So we cannot just say that is exactly equivalent to 22.7. Okay, it's approximately 22.7, but not exactly 22.7. So this is the golden ratio, and it's approximately 1.61. Okay, I don't know if you're familiar with that, but that's a symbol for the golden ratio. And of course, square root of 2. You see, all these numbers are non-terminating and non-repeating if we convert them into decimals. Okay. All right. So rational numbers, non-integers, fractions, decimals. So we have 1/2. These are just some of the examples, just to give you a clear understanding about these numbers. 4 over -3. These are fractions, decimals. Negative 0.5, negative, oh, sorry, 0.23, and you see that bar on top, that means it's repeating. So for the integers, obviously we have the negative. Let's say -4. 0 is just 0. Whole numbers is 0, and the positive. But for the natural or counting numbers, one example there is 8. Okay. Okay, true or false? The number 22 over 7 is an irrational number. Okay, the answer is false. That's correct. It's exactly there's an equivalent of that. Okay, it's not an irrational number. Although sometimes, again, some math teacher used 22 over 7 as a value of pi, but it's not an irrational number. It's a rational number. Okay, every fraction is a rational number. Oh, sorry, that's true, by the way. Whole numbers are also called natural numbers. Is that true? Nope, that's false. So whole numbers is 0 plus natural numbers. All right? Natural numbers are just counting numbers or the positive integers. Okay, this is false. Decimals are irrational numbers. What do you think about that? That's false. All right, let's go to the last one. Integers are composed of negative and positive numbers. Now, if you say true, then you're missing one component of integers, and that is 0. So this is false. It's composed of negative, 0, and positive numbers. All right. Okay, so let's go to the last one. Let's locate the following in the number line below by plotting. All right, so negative 2.8. So it's somewhere here. Positive 3 is obviously here. All right, so square root of 5, that's near the square root of 2. I mean square root of 4 rather, and square root of 9. Right? Square root of 9 is 3, square root of 4 is 2, but this is close to the 2. So I'm just gonna guess this. It's okay. We can just say that it is somewhere here. Okay. So for 1/2, it's obviously here. Oh no, not there. Right here. So this is our A, this is our B, C, and then D. All right, cube root of 8, I mean 6 rather, that's negative. Now this is between cube root of 1, which is 1, and then cube root of 8, which is 2. So between 1 and 2, negative. So somewhere here. But it's close to 8, right? So maybe here. So, right. This letter E. All right, so that's it for today. Thank you for watching. Have a nice day. Bye.